again. I'm Charles Lively, and I'll just be talking a little bit about making use of Python at NERSC. And tomorrow, or Friday, I'm sorry, we'll have a more detailed presentation by Justin Cook from the Programming Environments and Modeling Group on all of the vast programming languages and resources available. But we have a special section on Python because with the amount of data that most scientific simulations generate, most of our users are make use of Python in some way as well as Jupyter. So again, and also these slides were created by our colleague Daniel Margala, and he is a member of the Programming Environments and Modeling Group, and he is considered our Python expert. So if a lot of the tickets that you have that are really advanced and difficult, we tend to pass those over to Daniel because he's our expert. So we'll talk about a little bit about Python at NERSC. Lippy mentioned briefly about Conda and storing Conda environments, so I'll touch upon that. We'll talk specifically about the NERSC Python module. It's not your regular Python, as well as creating environments, installing packages, and parallel Python at NERSC on Perlmutter. So again, this is Python at NERSC, the Perlmutter edition, because Dalton is coming on the horizon. So using Python at NERSC, and Baby Yoda says welcome. So using Python at NERSC, in order to get started with Python, it's very simple. We have a number of different versions of Python that are available. The most up-to-date version you can simply load with module load Python as well as providing that version. And then once you have loaded it, you can enter Python to get started with it. And it is pretty straightforward in that sense, in that we do have that easily available for you to access and utilize. A lot of the more advanced things associated with Python are tied into Jupyter, which we'll discuss on Friday, and I believe Lippy's going to do that as well. And so one thing that we definitely recommend, um, and it should almost be a requirement when you have more advanced application environments and ecosystems, is making use of Conda for creating a custom environment. And what Conda is it allows for you to create a scientific environment or programming environment that has all of the necessary libraries and dependencies and everything that you need that is tied to the application or whatever type of scientific simulation that you are doing. And so we recommend Conda environments because a lot of times when you have complicated applications that require different libraries. Some of the libraries can, result in errors during compilation or making of them. And a Conda environment keeps a nice little sandbox that you can utilize specifically for each of your projects that you might be working on if you're working on more than one. And so once you do your module load conda command, it will automatically initialize conda. So you don't need to run a typical conda init that on other systems. And that's another thing. Lippy alluded to this before, but a lot of the packages and software environments that we do have been tailored specifically for Perlmutter because it's a pretty big, powerful system, and you can't use the same type of software stack that you use out the box on other smaller systems or like on your desktop or small cluster. So it's important to keep in mind and all of these little nuances and the differences that exist. And, it also will help you from, thinking you're going crazy because you're like, oh, I know how to do this, but, it's a little bit different on Perlmutter. And so once you do load the Python module and you can list your Conda environments and it can, list all of the available software Python packages that we have available. So once you do Conda list, it'll list all of the various packages, matplotlib if you need to do like any plotting, NumPy, SciPy. This is just a short snippet of all of the numerous programming environments that are available for you to utilize in creating your Conda environments. All right. Oh, let me go back. So, how do you create your own custom Conda environment? It's very simple. These commands give you a quick overview of what you need to do in order to create that. Again, starting with module load Conda, and then you want to do the Conda create command. And the dash n is going to give you the number of different um, option or allows for you to specify the name of your environment. So let's say you're doing like a climate simulation project. So maybe your environment name, I here it has my ENV, but maybe it might be my climate ENV, and then you can specify the packages that you want to use. Python, you can specify the version, any other libraries that are available, such as NumPy or SciPy as well. And then you do conda activate my ENV, and that will launch your environment for you to make use of. Another useful thing that you can do is, and another little note is that if you do which Python, it's going to default you to the available system Python, which is not necessarily the Python that you are looking for. So make sure you do the module load Python. You can also use Python from appropriate containers. So let's say the version that we have is there's a beta version that you want to try. You can also, try to launch that in a container as well. You got options. And so, a couple of tips when it comes to installing and managing your packages via Conda or pip. Make sure that with Conda, it can come in different what we call channels. So you want to make sure you recognize what some of those specifics are. You can use the -C default or C Conda Forge to see all of the different channels that are available in different configurations. And you can also check the packages that you have already installed, or if you need to clean up or remove any um, Conda environments that you no longer need by entering Conda list, and it'll list out everything. One thing that you want to keep in mind, again, are a version of Python and packages that we have available have different compiler wrappers that are optimized for performance on our system. So, we'll talk about MPI 4Pi and H5Pi as well, but for high performance. But we have different wrappers that you can utilize in order to take advantage of some of the more advanced Python components and libraries as well. And so we also make use of CUDA Toolkit heavily. And again, on Friday, Justin Cook will give you a complete overview of our programming environment ecosystem, which can be very exhaustive and overwhelming. But it's good to have all of those in options for what you have. And so, module versus a Conda package, you want to keep in mind that some of our modules, like the Python, is a module that we have available. We have our CUDA toolkit, which has other components that are also available for you to install in your Conda environment. But you want to make sure that you ensure that you don't conflict with the CUDA toolkit environment that's loaded by default. And so this is why it's important to kind of create your own Conda environment and ecosystem to utilize. All right. So, some of you may not need to use a parallel version of Python, but if you do, we do have it available with MPI 4Pi, and that provides you basically a Python interface that you can use for MPI. It is already available and with the wrapper within our Python module. So once you load that module to load MPI 4Pi, you want to use the programming environment GNU as well as the CUDA toolkit, and you can specialize any other any other environments that you want to include, or libraries or modules as well. And so you can do the module load those environments as well as the conda create, and you can provide specifications for the different environments that you need as well. And then conda activate will launch that specific environment. And you can use various other commands if you want to install or specify other type of libraries that you want to use as well. So one caveat that you want to make sure you're aware of is that any CUDA aware MPI that you need to make use of, it must have the CUDA toolkit loaded, even for code that does not use a GPU as well. So that's just another thing that you want to keep in mind. And a lot of these little nuances are also noted in our documentation. So you want to just make sure that you make appropriate use of all of our documentation. At the end of this slide deck, we have all of the pertinent links related to Python and Conda environments for you as well. And so you want to make sure you use pip with caution. Pip maintains a local package cache, and sometimes that can cause conflicts. So things that are packages installed for a specific user are not particularly confined to a particular environment. So you want to make sure if you use pip for installing packages, you want to make sure the location is specified specifically. And so you want to make sure you set Python user base to this directory right here for yourself. A couple of best practices for working with pip. You want to make sure you use it within your specific Conda environment. We Please do not use it outside of that Conda environment. It might introduce a whole caveat of conflicts and issues for you as well. And so, yes, with that, using pip, use it with caution. And And feel free if you have any questions as we go about. We're winding down, but we have a little time for questions as well. With a lot of the data that you might use, it may require for you to use significant data sources and require large scale processing. And so also with that, we have the capability of running Python at scale and in parallel. So we also want to make sure you use the flag -gn. You want to make sure you use a container in creating your environment, and make sure you specify that specific prefix that you want to use for that specific environment. As Lippy mentioned previously, with regards to creating Conda environments, we recommend that you install it, your environments in your own little project category under Global Common, and you can create your project and create your environment directory and all of your appropriate Conda environments that you want to make use of. So key things you want to do is avoid um, creating your Conda environments in home or in CFS. So because Conda environments can be very uh, consume a lot of data resources or storage. I'm sorry. So. And so other common parallel Python pitfalls, if you're not used to doing jobs in parallel, you want to make sure you have a good understanding of any of the resources that you need to utilize, specifically understanding maybe the number of threads versus the number of MPI processes that you might want to use, and making sure that the multiple of them, like number of processes per node times the number of threads, does not exceed the number of physical CPU cores per node. By default, you can also use the default worker pool size is used for multiprocessing, so you can get whatever is the specified value for the number of processes by just using the value from the OS CPU count module function. But that doesn't account for CPU binding. And also, you want to make sure that if you're working with nested parallel applications, that you specify the number of workers to use, and not just go with the defaults that might be available. And so, summarizing using Python at NERSC, you want to make sure that you make use of Conda environments or containers. That's just going to give you that safe, secure sandbox that you can, break something in private and not, break everything else that might affect other users in your project. Make sure you use global common software in your project directory um, for making use of it, and also understand the various compiler wrappers that we have available for Python, such as MPI 4Py. No need to run conda init again because once you load conda, it will automatically initialize. And make sure you use pip with caution. Avoid using the system Python that is available. That's just the default that comes on our Cray system. Make sure you also unexpected, watch out for defaults that or conflicts that can lead to errors and oversubscription of available resources. So it's just best to take things one step at a time as you try to build out your content environment and make sure you understand all of the pertinent libraries that you need to use. So just a little more. So let's talk a little bit about using Python on GPUs. And so when you get started with GPUs in Python, we have a number of different resources that are available. It's important to note that the most common Python scientific libraries like NumPy and SciPy, they are not inherently designed to make use of GPUs out of the box. And so there are various frameworks that we can make use that have replacement for those libraries. So drop-in replacements for like NumPy, SciPy, Pandas, and Scikit are available via CuPy as well as Rapids. We also have a number of machine learning libraries that are available that support GPU computing, such as PyTorch, TensorFlow, and JAX. Also have the capability to write your own GPU kernels, like using Numba or CUDA Python. And we also have, distributed memory Python wrappers as well, such as MPI 4Ply X, Dask, and cuNumeric as well. And many of these libraries have been adopted using the CUDA array interface as well. So you can pass array-like objects for storage and GPU memory. Again, we made a strong effort to try to standardize this around the general Python array API. So we have a number of those available, and again, it's more specific examples and documentation are available on our nurse docs as well. And so one thing you want to make sure that you keep in mind, again, that I mentioned previously, is understanding the CUDA toolkit dependency that's via the module. So, by default, the CUDA toolkit is loaded and the current version is, I believe, 11.7. And so you want to make sure you check your documentation requirements to make sure that that is appropriate for you. And if not, you can install other appropriate environments that will be able to make use of what's needed for you. And if you have questions about maybe understanding what's needed, again, we encourage you to submit a ticket. If you're working with maybe one of our community applications that's doing big simulations, the Nurse user Slack has a number of different channels for users that have other users that may be using the same application, library tools, or whatnot as you do. And if you have a problem, it's more than likely something that someone else has had before. So it never hurts to just reach out and ask and see if anyone else has had that problem as well. And I should be done in about 5 more minutes. So, with those toolkit dependencies, you want to make sure that with CuPy Conda Forge package, it'll pull that CUDA toolkit dependencies into that environment. And you also want to make sure with the CuPy Conda Forge that can pull those dependencies into your Conda environment as well. And again, all of these are, laid out specifically with more detailed examples in our documentation at this link below as well. So it's good for maybe test and try out some different environments and even, make sure you understand how to create them, how to remove and clean up and, become comfortable with managing your environments and as well as your data on Perlmutter. And so another thing is if you are new to working with GPUs is the axiom is your data really going to be beneficial or should it be ran on a GPU? And so a good rule of thumb to keep in mind is that really CPU processing is good for low latency, and GPU processing is good for high throughput or data that it can be easily manipulated. Like, you think about a lot of matrix multiplication and arrays that can be used. Those are going to be good for GPUs. And so if you're using an application or something that is not already ported for a GPU, but it makes use of a large number of arrays, matrices, or images, and the data set is able to fit um, good within the memory of the 40 gigabytes on the Perlmutter API A100 GPUs, and it's not like a lot of data movement that's needed to present a bottleneck, then it's probably going to be your application or whatever code you're working with. It probably would be a good fit to try and toy around with porting it or modifying or creating a GPU enabled version of it. Also, it's important to note we do have higher memory, 80 gigabyte GPU nodes available on Perlmutter that you can request through reservation as well. And wrapping up with some high-level best practices, please make sure you utilize Conda or a container environment. Um, we only touch briefly on containers in new user training, but we have more detailed trainings as well available, as well as as Lippy mentioned, the spin training that you can make use of as well. Please make use of our documentation. Our documentation is very thorough and extensive, and most of the time it has a number of the foundational answers that you might need. And if you are not able to find the resources that you do need, you can always reach out and submit a ticket. Again, the more detail that you provide in the ticket that you submit, the better. And what we mean by detail is let us know like what type of application that you're working with. Is this a batch or interactive job submission? Give us the full error. Give us your programming environment that you feel might cause that error. The more detail that you provide in your ticket, that will help us and enable us to get you a quicker resolution. So, and so again, welcome to NERSC. Again, please make use of Python productively on Perlmutter. And if you have any questions, we're here as a resource. You can reach out to us and also refer to our documentation that's available as well as submitting a ticket. And with that, did we have any questions? If you have not, please do make sure that you complete our day one survey as well.